In this video, really the last video of the trilogy of the SIEWERT bridge for the lab steps, we will show you now how to fabricate the occlusal face. That means the single zirconia multi-layer crowns on this PEEK framework. We always do a rescanning of the PEEK structure because over the years it showed that some details are not really milled as in the design, because the tools can get in there because of inclination. So there is a small discrepancy between the design and the milled framework. So it's better to scan it once again. The model socket always serves us as a reference point, so it's easy to match previous design on the new scan. Okay, here you see the PEEK bridge with the powder for scanning, and this step we do with a little bit more powder to make like a spacer for our individual zirconia crowns. Okay, so just a little bit more, not as thin as in the previous scan with the scan bodies. Here you see the scanning of the Junji PEEK framework mounted on the model. And now in ExoCAD we open a new project. I hope you are comfortable with the yellow dot to make the cursor more visible, because this project SIEWERT Bridge Phantom Zirconia. We select the anatomic crowns in zirconia, and utmost important, we raise the cement gap to the maximum, that's 0.1, and keep the minimal thickness of zirconia in 0.6, and select yes, we have a pre-op model. Okay, choose the A2 color, and here the antagonists in the lower jaw, and save this project in order to go to the design of these single zirconia crowns. So we will go to the folder on our PC where we store the files for this project. You see we have more and more files in this workflow for the SIEWERT bridge, and here we choose the recent scan of the framework, the antagonist, and our wax hub. We put the upper jaw in a common insertion. Here we see all our information. We skip the small design file, and now we go to the step where we select the margin of each tooth on this 12-piece SIEWERT bridge. This is a manual step with the help of the magnetic tool. So here we mark step by step, and if the line is closed, it turns into green, and we still have the possibility to fine adjust this line on these notes. We select this one, So all the surface being in between this green line turns to gray. And it is important to understand that this line is not the outer margin of our future crown, it is the inner margin. That's why we have in the interdental space, we leave a space between these gray areas. You will understand this in the further process. So we go a little bit faster through this process as it repeats in the same manner in each tooth. So Elisabeth has already a lot of experience with these cases, but it's really more or less easy to learn. And I hope that our videos are an important help for you. We are finishing this step in the last tooth, number 26. So these steps we made in the assistant window, which determines the margin line. As in the steps before, we check the line from all view angles. We click next, and now Exocad is calculating the basis of the structure. You see it here in yellow. Above each crown basis on the PEEK framework, Exocad has a green arrow, and this is the proposed insertion axis for each crown. So what we will do now is to fine adjust this insertion axis for each one of these 12 crowns. What you can observe is that the shape of the PEEK framework is very similar to the shape of a prepared tooth in the patient's mouth. And that is very important to assure a perfect cementation of the zirconia crown on the PEEK framework. On the other hand, it's very easy to remove a zirconia crown from the PEEK framework in case of a fracture due to an accident of the patient, and to mill a new crown again. So here we are on the last tooth, the 26, and we finish this step in the workflow of the zirconia crowns. Here on our assistant window we have the cavity, the margin that we leave unchanged, and we have the retention. And we put the size here to 0 and applicate it, and now Exocad is calculating the interior structure of the crowns. In the beginning, when we defined the parameters of our project, we set the cement space to the maximum, that's 0.1 millimeters. And now here in the cavity folder of the assistant window, for the basis of this structure, we add another 0.05 millimeters to this cement space. In the margin folder, we set the 0.2, the angulation, to 0.2 millimeters. Please click Next. Now ExoCAD is generating the minimum thickness structures of each crown, and it's showing the result in reddish brown on our framework. When this is done, ExoCAD shows us the antagonist and the wax up we had in the beginning. So in yellow you see the teeth of the library, we get them away. In blue you see our wax up, and beneath we have our base structure for the crowns. And what we have to do now, once again, is to match these teeth of the library into our wax up by hand in order to pre-adjust the position. In a two-step process, we will now finish the shape of our single zirconia crowns equal to our wax up. So when they are placed more or less by hand, we go next. Now a calculation process starts. You see the changes in shape. And if this is done, we will click Next. And here we select to adapt the situation to our model teeth. This process is now going on, and when it is finished, we have our zirconia crowns more or less in shape on our model. This looks already quite good, but I'm sorry, we have to make some more adjustments. In the interdental space, ExoCAD leaves some defects after the automatic calculations we have to correct. You see that here. So with our brushes we smoothen that, and we go over the margin of the crown. It's important to know that these adjustments do not have really effect on the appearance, on the general appearance of the teeth, and they do not have any effect on our occlusion. The list where we can select a single tooth here in the upper window in gray has no chronologic order. So that's why we started here in the first place. That's the 1-3. So now we search in the list the 1-6 and go through all these teeth step by step, doing the same thing. You see here the fine adjustments on this molar. We do not touch really our occlusion. You may have observed that. And then we go now rapidly through the rest of the single crowns. What we really earn with so much work on the cut process is that finally we will have crowns that adjust on the PEEK framework without any further refinements. Here we show you what we are doing to adjust a contact point with this second molar we left there in order to have a reference for the vertical dimension. And so if everything is done, we will extract this tooth in the phantom's mouth. So you see here these single crowns. See the contact point, it's a little bit strong, so we get it a little bit smoother. The absolutely last step in the workflow for the zirconia single crowns on the YunMed PEEK framework is to control and, if it's necessary, adjust the interdential contact point. You see it here. We do it in every interdential space, and this precision during the cut process makes it possible that our sintered and glazed zirconia crowns fit on our PEEK framework without any more refining of the ceramics. Now we finish this step of the workflow to control and adjust the interdential contact point. And if this is fine, we see the final result. We will go next. And now Exocad is really calculating these 12 zirconia single crowns. What we do now is we export each crown as an STL file with its proper name in order to send it to the CAM process. That is very important to save these STL files for the future, because if there is a fracture due to an accident and we have to repeat one or more crowns, then we need these STL files in order to make an exact repetition of any of these 12 crowns. Okay, after designing the zirconia single crowns, it's time to get this zircon disc into the milling machine. We use here from Siladent Zircon Biostar for this work. It's a multi-layer disc, A2. If you are comfortable with another one you're using, there's no problem. Okay, but we get good results with this one. So we get it out of the box. You see it's already used for some milling, that's why we have here this mark. And we get it into the machine. We always tighten it carefully, step by step, in order not to damage the fragile disc with our support. Okay, finished, ready. After milling, we take the disc out of the machine, clean the connectors of the crowns, and then we can place these unsintered crowns into our ceramic tray on ceramic pearls, and we close our sinter oven. In the chamber, these wolfram elements are able to generate 1650 degrees Celsius. Our sinter program first elevates the temperature to 900 degrees and then up to 1650 degrees. After that, plateau starts a programmed cooling process and the sinter oven reopens at about 200 degrees, still warm. And then the miracle occurred. So this white crowns changed into beautiful real size ceramic crowns. The preparation for this sandblasting process, it's important, so we protect our connection with the multi-unit by analogs, by multi-unit analogs, this precise surface. So now let's do the sandblasting. So after the sandblasting is done, we have in the surface where we want to have the sandblasted effect this opaque appearance. I don't know if you can really see it, it's a little difficult. To get away rest of aluminium oxide, we just clean it with air, very important. Don't clean it with steam. Okay, just intensively with air and nothing else. And now we will put our bonding on there. Now we use this Visiolink primer. We got some drops in here. Okay, close it tightly and then we apply a thin layer onto the sandblasted surface. It's very important we do just one layer, not two. Now we will place that in our light oven for 180 seconds. After the light curing of the bonding is to put the opaquer on it. We use here the Gradia opaquer and OA2 because we have a A2 tooth color. Okay, so we get some of the opaquer here. Our brush. And then we apply a really thin layer. Before the glazing, the crowns have been placed on the framework to check the occlusion in the articulator and, if necessary, readjusted. The 12 multi-layer high-translucent full zirconia crowns are now glazed and prepared to be cemented on the YunMed PEEK framework with the bonding and the opaquer applied. Without any further processing, the crowns can be precisely placed on the framework. And now we start the cementation process. We get the crowns of the framework in a precise order. And then we have to prepare the inner side of the zirconia single crowns with a Silano. We use in this case the ceramic primer 2. With one drop of the ceramic primer 2 from GC, we wetten the inner side of each crown and allow to evaporate and dry for about 2 minutes. Now the cementation process will start. It is best done with 2 persons. We use this dual composite cement from GC. We apply with the Automix tip a small quantity inside the crown, and then immediately we place it onto the framework, being carefully that in all the border some excess of the dual cement is coming out, and then we clean it carefully. And meanwhile, the other person can prepare us the next crown. With the dual cement filled in, we check the perfect fit. And before the cement of the crown, the first crown we placed, is curing, we place the next one and carefully remove out of the interdential space the excess of the composite. After cementing all crowns and carefully get away the excess of the cement, we light cure it for 360 seconds, and then we get away the smear layer with alcohol. And we start the polishing process. Although the bridge is veneered with these single ceramic crowns, we have still a bridge with a bone-like elasticity. That guarantees us the fit on the model and a perfect passive fit in the patient's mouth. We get very nice aesthetics. We have a biocompatible metal-free bridge with a very low weight, in this case of just 22 grams. Thanks for watching. I hope you enjoyed the video and we could explain you the whole procedure to make this bridge possible. Goodbye.